In this video, we're going to discuss two specific types of probability and how we calculate them. In our last video, we learned probability is the likelihood that something is going to happen. It's a measure of the odds of something happening. And the question is, how do we calculate it? And there's two ways. Theoretical probability is calculated from an understanding of how the system works. For example, coin flipping. I don't need to pull a penny out of my pocket and start flipping it. I know how coins behave. They have two faces, a heads or a tails. If that coin is equally weighted and fair, I should have 50-50 chance of getting a heads, 50% chance of getting a tails. I didn't need to actually do the experiment to know that. That's just how the system is structured. And in that case, we calculate the probability of event A happening by taking the number of ways to get outcome A and dividing it by the total size of our sample space, or the total number of outcomes. If we go back to our flipping a coin example, it would be the number of ways to get tails, for example. And there's only two outcomes, heads and tails, so there's one way to get tails. There are two outcomes in my sample space, heads and tails, and 1/2 is 1/2 or 50%. Empirical probability is calculated based on experimental data. In this case, we go out and we collect data from a sample of people, or we repeat an experiment over and over and over again, and we count the number of each type of possible outcome, and we build a frequency table, and then we use that frequency table to calculate our empirical probability. So the first thing is the actual data should be in the form of a frequency table. And then to calculate the probability of event happening, it's the frequency of event A in my table. I go to the A row and pick off that class frequency, and then I'm going to divide it by the total frequency. You'll notice that both of these fractions have very similar structures. It's event A on top, total on bottom. Sometimes we're pulling that from the structure of the system. Sometimes we're pulling it from a frequency table, but it's always the number of ways to get the thing we want on top, total number of possible outcomes on bottom. And we're going to do two quick examples. So example 1, you flip 2 fair coins. What is the probability you flip 1 heads and 1 tails? So I know this is theoretical. I don't actually have to flip 2 fair coins to figure this out. I know that my sample space, S, I can flip 2 heads. I can flip a heads and then a tails and then a head, or 2 tails. The event of interest is 1 head and 1 tail. And it didn't specify order, it just said 1 of each. So looking at my sample space, the two things I'm interested in are head, tail, and tail, head. That's 1 head, 1 tail. So the probability of getting 1 head one tail is the number of ways to get one head and one tail, and there's two outcomes that fall in that category, divided by the size of my sample space, and there's a total of 4 outcomes. When you report your answer, you can report your answer in 3 forms. You can report it as an unreduced fraction, or a reduced fraction if your calculator auto reduces for you. I prefer the unreduced fraction so I can see how these numbers connect back to the sample space they came from. Or you can report it as a decimal, and 2 divided by 4 is 1/2 or 0.5. Or you can take that decimal and multiply it by 100% and turn it into a percentage. In this class, we're typically going to do one of those first two. It is most common to use an unreduced fraction or a decimal. And once we move on to probability distributions, we're going to want decimal form. So I would encourage you to get used to reporting numbers in this form. All right, let's go ahead and try one more example. So this one says the distribution of students in a local high school district is shown below. What is the probability that a randomly selected student in this district attends North Salinas High School? So they've given me a frequency table, high school, and the number of students, which I know is code word for frequency. And they've identified North Salinas High School. So I'm going to come to my table. I'm going to circle my North Salinas High School row. That's this row here. So I know that the number of ways I can get a North Salinas High School student is 2,125. And when I go to build my probability, so probability the student goes to North Salinas High School, it's going to be that number, the frequency of North Salinas High School, divided by the total frequency, and we don't have that yet. So I'm going to go ahead and grab a calculator off the screen, and I'm going to add those 5 numbers together to get our total. And I get 11,014. So the denominator of my probability fraction is 11,014. And I'm going to go ahead and convert that into a decimal. So 2125 divided by 11,014. And I get 0.19293626, keeps repeating, going over and over and over again off the calculator screen. Or 19.29%. Again, I would recommend reporting the decimal answer. And when reporting probabilities, you're going to notice it is most common to report these to 4 decimal places. And that has to do with probability tables for things like a binomial distribution or a normal distribution that we statisticians used before graphing calculators were easily accessible. It is acceptable to round it to 3 or 4 decimal places. You should never report a probability as less than 3 decimal places. All right, if you have any questions on the difference between theoretical and empirical probability, or how to calculate those based on frequency tables or understanding systems, shoot me an email or drop by office hours. Otherwise, I will see you in our next video.